Okay, so if you remember when we took the shortcut from last unit of expanding what we call this a perfect square trinomial, right? We just take this first term and we square it. So we get y is equal to x. So x squared. And then we take the second term, h here, and that gets squared, right? And it's always positive because we're squaring it. What was in the middle again?
X times negative h times 2.
Yeah. So we take these two things, we multiply it, and multiply by 2. So we get, and we keep the sign, so that stays as negative 2xh, right?
Yeah.
So that was our shortcut to getting, to expanding it. So the question is, what is the vertex of this quadratic though? What's the vertex of this quadratic? Sabrina? H comma 0, how'd you get that?
Because the H represents the theme, and it's not there.
Okay, so which form were you looking at basically?
That vertex.
Yeah, so you guys remember the vertex form? Right, and so when we did the whole marble thing falling off the track, right, we started off with vertex form because we know what the vertex was. So what is that form again?
Y equals a, bracket x minus b plus c. Squared.
Yeah, x minus c quantity squared plus c. Right? So that was our vertex form. Y is equal to a x minus c quantity squared plus c. So when we have this over here, y is equal to x minus h quantity squared. Well, what's our a value in this? What's our a value? 1. 1. Our a value is just 1, right? And here, I could just add 0 to this equation, right? Can I just add 0 to the equation and still keep it true? It doesn't change it whatsoever, right? Pardon?
No, I did something extra.
Oh, okay. So what happens is, this was now our x coordinate of the vertex. What is the other name we gave for that again? X coordinate of the vertex? But there's a specific thing. Yeah, axis of symmetry, right? And this is our y coordinate. Okay, so therefore our vertex is h comma 0, as Sabrina already said. Okay? So it's kind of cool when we get this x minus something quantity square. We get that perfect square, right? Trinomial. We can almost see what the vertex is. Okay? If it was a perfect square trinomial. What happens when we have this one? Actually, let me ask this. So for this equation, y is equal to x squared plus 18x plus k, what value of k would make this a perfect square trinomial? This sounds familiar. This was actually a homework question from Unit 5 way back when. Right? It was in the textbooks, also was in the handout that we gave out. It was a little bit confusing at that time. Hopefully it'll make more sense after today. So what value of k do we want so that this is a perfect square trinomial? What value? What value? Anyone brave enough other than Eric? Haley? Guess? Stab in the dark? 9? Okay. Well, 9's a pretty good guess. Is 9 a perfect square? 9 is a perfect square, so k has to be a perfect square, right? So 9 is a pretty good guess. Any other ones? Anybody have anything different? Alex? Oh, Eric? 81? Is 81 a good guess? Is that a perfect square? Right? Square root of 81 works out to be 9, so it's a perfect square.
Oh, yeah, right.
Well, how do we actually know which one it might be? How can we determine what that number may be? Well, how did you get 9, Haley?
Perfect squares.
Okay, so just,
It goes into 18.
okay, so 9 went into 18, right? So we know that has something to do with that middle term, or that term that has just x in it. Okay, so how would you get, Eric?
Well, the 2, the 81, the 9 and the 9, the factors of it, like the 9 and the 9, they have to go into the middle one.
Okay, so you're using the whole decomposition, right? So 9 plus 9, right? We need to add 18. We need two numbers add up to 18, but they need to be the same, right? And then they have to multiply into those two numbers. So that's sort of how you got it, Eric?
And divide them by square.
Yes. So that's another way to think of it. So there's nothing wrong with how Eric did it. Basically, he basically doing the same thing. He took the middle term. He realized that if I decompose that, it has to be two of the same numbers, which is 9 and 9, but they have to add up to a certain number, which is 9 times 9, which is 81. What happens if we go back and look at this? Notice that this middle term gives us something like 2xh. Actually, I should have wrote this 2hx. So what we realize here is that 18x, we want to figure out what the h value is. It's equal to 2hx, right? So here I want to isolate for h. So I'm going to divide both sides by x. And h is equal to 9. But what is it that we want for a perfect square trinomial? What's that constant? It's actually h squared,
So it would be,
right?
yeah.
So therefore, k is equal to h squared, which is equal to 9 squared, which is equal to 81. Okay?
No.
So therefore, y is equal to x squared plus 18x plus 81 is a perfect square trinomial. You sit up there?
Yeah, sure.
Let me move my guy. So what we see here is basically, the quick formula is what Eric said. You take your middle term, right? So take the coefficient of x. Of x, divide by 2, squared. Okay? Basically same thing as what the other Eric's saying. We're doing sort of the same thing, right? So what's the vertex of this quadratic equation then? So what's the vertex of this quadratic equation? What's the vertex of this quadratic equation? You write this out. Not up here for your amusement, right? What's the vertex of this equation? This quadratic equation, what's the vertex? 8?
No, as a weight.
Oh, wait. So while we're waiting for you, Zach, Sabrina,
It's -9 comes
-9 comes, how did you get that so fast?
0.
because we got to square bracket x plus 9.
Yeah, I mean, the whole reason why we're getting the perfect square trinomial is that we know that we can factor this now as y is equal to x plus 9 quantity squared. So just like in our other example, therefore we know that the vertex is -9, 0. Right? So if we get in a perfect square trinomial, there's a perfect square trinomial, it's easy to pick off the vertex because it's in vertex form. X minus something quantity squared. So what happens if we have something like this now? Like an equation that looks like y is equal to x squared plus 18x plus 75. How do we get the vertex of this equation now? Well, we could try to factor it, but right now I can tell you that there's no two numbers that multiply to 75 to add up to 18. So we can't rely on our old PSI method.
Just
Right.
did.
Really?
No, I was joking.
I know. I know you're joking because I know there's no two numbers. Right? So it'd be nice if we could. So we can't quite factor this.
This is
So how do we get the vertex?
just the x coordinate 9.
Well, let's try
minus
this.
minus 9.
Why do you say that, Zach?
Because that's what I got.
That's what you got? By factoring?
By completing a square.
Oh, so you already know what we're doing. So what did I just do here? I rewrote the equation, put a big blank in between. Did I change the equation at all? No. Right? But if I look at this part of the equation, how can I make that a perfect square? How can I make this part of the equation a perfect square? Well, we know what value it has to be. What value it has to be, we need to add to it. 81,
Oh, 81.
right? If we do a plus 81 here, right? We do a plus 81 here, we get a perfect square, trinomial. Awesome. Is what I did legit? We just add 81. Thank you, Eric. So I could add 81, but that's not the only thing I can do. I have to make this equation true still. So what I can do is I can subtract 81 at the same time. So the net effect is I'm adding 0. I'm adding 0 to my equation. Right? Haven't changed it, still kept it true. I just chose to represent 0 differently. Plus 81, negative 81. Now what I can do here now is, I can take this, and I recognize, oh, there's my PST. So now I can say PST because
Oh, you
it
just
doesn't mean
decided,
anything else, we don't have the
like,
sales tax anymore. So now we have x plus 9 quantity squared, right? So we're going to just take that part and factor it. We got perfect square trinomial. And we're left with minus 81 plus 75. Right? Well, yeah, now we can simplify, right? 81 and 75. Negative 81 and 75. So what we're left with now is y is equal to x plus 9 quantity squared. Let's say minus 6. Now can you tell me what the vertex is?
Negative 6.
Sorry?
Negative 9 and negative 6.
Yeah, negative 9 and negative
Oh
6.
yeah.
So therefore the vertex is at And we know that this is true because everything we did in here, from getting from here to here, is mathematically true. We kept that equation consistent, the same, right? But now we just put in a form that we know what the vertex is. So when we start off unit 4, understanding what this equation, what this quadratic means in vertex form. And once we have that form, there are so many things that we could talk about it, right? Do we know if this one opens up or down?
Yeah.
Does this one open up or down? Up. What's the stretch factor? What's the stretch factor?
One.
Yeah, there's an implicit 1 here. Stretch factor is 1. Does it have a maximum or minimum? There's a minimum of -6, right? So once we have this form, we can find out so many things about this quadratic, this parabola. But most of the time, we're not given to this form. We're given into this expanded form, like our original equation. So if we get from that original form, what we call standard form, right, into vertex form, we could do a lot of wonderful things with that. We could graph it, etc., etc. So it's almost like we come full circle. We start off with the form that we said, this is wonderful, we know so much about this quadratic. If we can get there, it's awesome. So the last 2 units were spent now getting there. Any questions on that? Yes, sir.
Find the first 81, you just define the middle number, and then square.
Yeah, so basically it was what we did here. So we took the middle number, squared it. So we could practice that for this equation now. How do we find the vertex of this equation? So again, we could try the factor, right? Again, factor is not going to work in this case. No 2 numbers are going to add up to 12. We'll multiply to -14. We get close, but not quite. Right? It's a 2x squared. Is this a perfect square? No. So it's going to cause us some grief because the previous example was easy. X squared was a perfect square. So what we can do with this is we could do what we call partial factor. Right? We're going to partially factor out the 2 just in these first 2 terms. So we'll have x squared plus 6x minus 7. Good question, Sean. So normally we're used to factoring out a GCF. I know you're watching the time, man. Okay. I don't know, I think somebody's finishing tabs. So normally when we talk about the previous unit, we talk about factoring a GCF, right? So in this case, greatest common factor of these 2 terms is 2x. But the goal of what I'm trying to do is I'm trying to keep this what's inside the brackets here a quadratic still.
So just take out the number.
So we just take out the number, right? We just factor out the coefficient of an x squared. So now we're left with 2 times x squared plus 6x, and the minus 7 is just all by itself because we didn't do anything to it. We didn't factor out 2 out of it. So the question now is, what we have in the brackets, what can I do to make that a perfect square? How can I make this a perfect square? Right? So we take the form that Eric gave us before, the coefficient from the x, which is 6, divided by 2, which is 3, and then we square it to get us, right? But can we just add 9? 9 is 9. Where would we put the minus 9? Inside the brackets or outside the brackets though? Inside or outside the brackets? Inside. Because we added 9 on the inside, we need to do the same thing on the inside as well. It's almost like you treat this thing inside the brackets as its own separate entity. So you have to work completely within the brackets. So now I can rewrite this as y squared 2 times, well I know that that is my perfect square trinomial, x plus 3 quantity squared, I still have my minus 9. Minus 7. Is that vertex form? Are we done?
No.
No, not quite. We have an extra set of brackets there. So we need to remove that by doing our distribution rule,
Two is just
right? So we take our 2, and we want to multiply against this and against that. So we want to distribute that across. So we get y is equal to 2 times x plus 3, 20 squared, plus 2 times negative 9 minus 7. So now we see why it was important to keep that negative 9 inside the bracket, so else we would have been off by a factor of 2 or a factor of 9. So now we simplify. So we'll leave this part the same. Plus 2 times negative 9 is minus 18, minus 7, so I get y is equal to 2, x plus 3, minus square minus 45. Now how do I know what my vertex is? Therefore, vertex is, sorry?
3 and
3, negative 25? Three, negative 25? Negative 3.
negative.
What part is going to make this 0? So same thing as before, what's that going to make that 0? It's going to be a negative 3, negative 25. Okay, any questions regarding that?
no.
So there's two ways that we can find the vertex, right? We could go back to what we learned last class or reviewed last class, finding the x-intercepts and doing all that work. Or if we could do it this way, we'll call completing the square, right? We can also find the vertex this way. So work on this example by yourself, and we'll pick it up in a couple minutes.